Here we have a question that has a function that's a fraction, and they want us to find where is f prime of x equal to 6. Okay, let's bring it on down. So we have f of x equals x over x plus 7. So we get it. Start by, they want the derivative, right? See that prime mark right there? We gotta take the derivative. So let's take the derivative. How do we take the derivative of two functions divided? Can we just do the top, do the bottom? No. Hope you know that that's not allowed. That when you've got two functions divided, the derivative, there's a special rule. They take turns. The first one goes, the second one just sits there, minus, the first one just sits there, and the second one goes over the second one squared. That's called the quotient rule. Quotient meaning divide, the divide rule, right? Two functions divided. So you got to take the derivative. So, okay. So what's the derivative of x? Well, it's just 1. Why? Because there's an invisible 1 power, comes down to the front, and then subtract 1, x to the 0 vanishes. So just 1 times the denominator just sitting there, minus, oops, it's a big sloppy minus. There we go. Minus, and then the top just sits there times the derivative of the bottom. What's the derivative of the bottom? Again, it's 1 because as x to the 1 comes down 0 and the derivative of the 7 is just nothing. Derivative of a constant number like 7 that doesn't have an x is just 0. And then over the bottom squared. So can we clean that up a little bit? I believe we can. What do we have here? Distribute the top. Boom, boom. It's just going to be x plus 7 minus 1 times x is just x over x plus 7 squared. And then these cancel, huh? So this is just going to be 7 over x plus 7 squared. Okay, we took the derivative. There is the derivative. Now, they want us to know where's the derivative. Find the value of x where the derivative is 6. Okay. So we're going to say, okay, so they want to know where is this derivative equal to 6? So where is this function, which is 7 over x plus 7 squared, where does that equal 6? There's the derivative, right? I got to solve that equation for x. How do you solve that equation for x? Well, when you got a denominator, you're going to multiply both sides, right? You can do the same thing to both sides of an equation, multiply it to get rid of that. So you get 7, whoops. There we go. Keep the color the same there. 7. Now, how do you multiply this out? You just square the x and square the 7. I hope you know that's wrong. You make those kind of mistakes, your life in calculus will end. I don't mean to be dramatic, but it will. You have to learn those rules. I hope you know that. No, you can't do that. Instead, what do you have to do? You have to write two of them like that. Remember? You can prove it with numbers. 2 plus 3. If you square it, you know that that's 5 squared, 25. You can't just square the 2, square the 3. That would be 4 plus 9, 13. See how that's garbage and wrong? It's not true, huh? Just proven again. When you have two things added or subtracted and they're squared, you can't just square the first square thing. You got to write two of them and do the whole FOIL thing. Okay, so what do we let the 6 sit out there for a minute and go boom, boom. X squared plus 7x, boom, boom, plus 7x plus 49. This problem's getting bigger. It's not getting better, it's getting worse. And then, okay, so then let this 6 go boom, 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 distribute through. 6x squared plus 42x plus 42x plus, what's that, 240 and 54? I think it's 294. And that 240, 54, 294. Yeah. Okay. Now what? This is where you start to think like, am I doing the right thing? This problem's it's getting worse. It's going crazy. No, we're on track. Okay, but now you need to know, how do we solve an x squared equation? It's going to come up a lot in this course. Let me write it somewhere where we have some room, actually. Let me put up here. Yeah, how do you solve an x squared equation. Step one, you got to get, see, we see x squared. We go, oh, no, it's x squared. You got to get 0 on one side. That's the first step. So subtract 7 from both sides. What do we have? 0. Whoops, that's a box. 0. We have 6x squared. 42x and 42x is 84x. And then 294 minus 7, I don't know. 4, 3, 287, I think. Yeah, okay. Boy, this is kind of getting awful. Okay. Um, so now that's step one, get 0 on one side. Step two, this was step one. Step two, the quad. Our friend, the quad. Remember him? So we're going to go negative b plus or minus the square root of b squared is b squared. That's 4ac all over 2a. That's what we got to do. So here we go. This is A. A is the 6. B is the 84. C is the 287. Okay, get a little room here. Okay, so here we go. Negative B. B is 84, so negative plus or minus square root of B squared minus 4 times A times C. This is awful. All over to A. Ooh. Okay. Okay. Let's see what we got. So negative 84. Plus or minus. Okay. Definitely got to use your calculator. So, in fact, I would probably just go right to decimals. Let me do that with you. I'm going to just type it in. 4, 6, 287. Yeah. I'm just going to go right to decimals. Here we go to Desmos. Okay. I'm going to say, right, Desmos, give me that big square root part. In fact, here, let's just take the whole thing in. What is the whole thing? It's minus 84 in the front, plus or minus the square root of 4 times 6 times 287, all over what? 12? 2 times 6, 12 on the bottom, right? This is just 12 on the bottom. So let's go type that whole thing into Desmos. That's what I'm going to do. So say, okay, Desmos, give me a big fraction here. Was it minus 84? I'll just start with the plus. Plus square root of 84 squared minus 4 times 6 times 287 minus 4 times 6 times 287 all over, what was it, 12? And there's one of the answers, minus 5 point. Oh, do they want an exact? Oh, yeah, they do, don't they? Let me see. Let's go back up. Give exact. Yeah, see right here? Give exact answers, no decimals. So, Desmos. Okay, Desmos can still help us. Let's go back. We just can't do the whole thing on Desmos. So just do the square root part. Square root of 84 squared minus 4 times 6 times 287. No, I guess, yep, get rid of the square root. Just do what's inside there. Just do the 84 squared minus 4 times 6 times 2, 87. Okay, so inside is 168. 168. All right, let's go back. So that's 168. So we go back, we go, okay, this inside is 168. The bottom is 12. All right. I think you could probably just type that. Those are two separate answers. And you could just type that in and it will take it. What I mean is you could type in minus 84 plus the square root of 168 over 12 for what is it one wants the greater and the lesser. So the greater will be the plus. Yeah, that's the greater. And then the minus 84 minus square root of 168 over 12 is the lesser. How do I know it's lesser? Well, it's minus, right? So the one that's added is going to be greater. One subtracted is lesser. Now, I'll show you how to get the simplified answers they got. But I just want to tell you, you don't have to do all that, right? You got plenty to do in calculus. You can just type this in. It'll take it. It's good. We're good. But you might be interested in how did they do all that? Well, you'd have to simplify the square root of 168. Do you remember anything about that? You got to do a factor tree. Two, just use your calculator. 2 times 84. How do I know that? I just took 160, just divide by 2, you'll find it. I don't got time to go to decimals. 42, 6 times 7, and 6 is 2 times 3. What did I do there? I broke it down and I found out all the little primes in a 168. So square root of 168 is square root of 2, 2, 2, 2, don't lose any, 2, 3, 7. 2, 3, 7. You tracking with me? I found out all the little building blocks, those are called prime numbers, that make a 168 by just dividing it all down. Why did you might wonder, why didn't you put the 7? Or I did 7. And why didn't you put the 6? Well, because 6 broke down to be 2 times 3. He's not a building block. I didn't underline him. I underlined all the numbers that couldn't go down any further, primes. If you multiply this together in your calculator, goes back to 168. That is a 168. Now, what do you do from there? Square roots are a 2 for 1 deal. Two twos inside sends 1 2 outside, so it becomes 2 on, they're gone. The 2 goes to the outside, so it becomes 2 square root. Now you might, and then just multiply these together. What's that? 2, 3, 6 times 7, back to 42. It's 2 root 42. Now you might wonder, wait, why'd you do the 2 for 1? Have you not seen this before? Square root of 9. Think about it with me for a second. You know it's 3, right? Think about what just happened there. What is 9? Two threes. Two threes inside is what? 1 3 outside. That's what roots always do. They're a 2 for 1 deal. So that's what we do. So you just break it all the way down to all the little pieces. Look for any matching pairs. 2 inside sends 1 outside. They're gone. So 1 2 outside. And then there's no other matching pairs. So they just remultiply to make 42. All right. So that means we have, I know this is a pain. That's why I didn't show you the simplification at first, because I knew it would be painful. So minus 84 plus or minus. Now we simplified this root 168 to be 2 root 42. 2 root 42 all over 12. Okay, now what can we do with that? Well, can we just like cancel 2 into 12? Well, remember added, subtracted items, you can't do that. But you can separate them like this, right? Because the 12 is dividing both of them. And then, is that like, yeah, that's just minus 7, right? That's just 70 and 48. Yeah. Plus or minus than 2 go to 6, root 42 over 6. I think that's what they said, right? Minus 7 plus minus root 42 over 6. Um, no, what did they do? Oh, they did a weird thing. I'll show you, but you should not do that. That's just wonky. I don't know why they did that. I mean, it's okay, but ours is better. Um, um, I'm not even sure I know how to do what they did. Oh, I could. But here, let me show you that theirs is. Let me do with theirs. They did a weird thing. They left the root in the denominator. I don't know why they did that. It's fine. It's okay. But let me prove it's the same. To get rid of that root in the bottom, you'd multiply top and bottom by root 6, right? And that'd be what? Root 42. On the bottom, it's root 36. And what is that? It's 6. Say root 42 over 6. Same thing here, root 42 over 6. We're right. Ours is a little cleaner. Ours has no more roots in the bottom. So there's the simplified answers. There's how you would simplify that. I'm not making you simplify that, though. There'd be the greater lesser. It's totally fine again, just to leave it this way and this way. So let's recap one more time. That was a lot of work. What did we do? We took that fraction and we took the derivative. How to take the derivative of a fraction, the quotient rule, which means they take turns. Derivative the top, the bottom one just sits there, then the top sits there, the bottom one's turned, or the bottom squared. So I did that. Did the derivative of the top, which is 1, bottom sits there. Then the top sits there, derivative of the bottom, which is also 1, over the bottom squared. And then I distributed Canceled, got this. And then I said, okay, they want to know where the derivative is equal to 6. So I said, where's the derivative equal to 6? Multiply by the denominator. Both sides cancels out. Distribute it all here. When you see x squared, you go into the game plan, get a 0 on one side, and then quadratic formula, A, B, and C. Plug into the quadratic formula. Take this inside, type in a Desmos 168, and then you're basically done. You don't need to do all that other simplification. Just write the plus version and the minus version, and you're done. There we go.